Nearly gone.
Nearly gone.
Just chopping your head off, I'm afraid.
Yeah.
Alan, next time you use it, give us a shout. Bring your GoPro. And just set it in the
Yeah. We were trying.
No, I just keep losing your head. Dear God.
Losing my head.
Yeah.
You'll have to hold it.
Yeah, I'll have to just
It's gonna
get it up a bit.
Your arms
Yeah.
are going to be dropping off by the time we finish, though. But
No, I'll not be so bad. I'll just hang on here. Go on.
fair enough.
We're recording now anyway, so whenever you're ready, we'll just take it and then filter it after.
Shall we kick off then? Well, people have been asking for this one for quite a while, so I decided I'd eventually put it together and do it. So this one is the memoirs of what it's like to be a BBC transmitter engineer back in the 1980s. Otherwise known as a misspent youth, otherwise known as now you're going to find out why I know so much about RF. For the rest of you that like pictures of high power transmitters, I mean this is the radio amateur's equivalent of transmitter porn, I guess, because you're going to see lots of pictures of valves and equipment and just drool over them. So let's get started anyway. How did I get into it? Well,
I'm a 9 to 5.
if you were reading Practical Wireless or something back in the days when I was a teenager, you might have come across that advert, which was the very advert that I saw, which was they were looking for technical assistants, and I'll explain that to you in a moment. But if you notice, if you read this, top line there, if you are interested in turning your amateur radio hobby into a career, then consider applying to us. Now, these days, amateur radio is just like, we just annoy people, we just get in the way and everybody wishes we'd go away and mind our own business, do our things somewhere else. But back in the 1980s, we were the people that BBC Transmitter Group wanted. They actually wanted radio amateurs. And shockingly enough, a lot of the people, not all of them, but a lot of them that were actually on the crew were amateurs. There was a lot of people. And of course, for an amateur, it was a dream come true because you had access to all ridiculous levels of power, workshops, test equipment. You could bring your own stuff in and work on it out of hours on the station. It was fantastic. And the pool of expertise that you had to soak up was second to none. Plus, it was an awful lot of fun. The job itself was the best job I've ever had. The life that went with it, not so much, which is why I stopped doing it in the end, but we'll come to that later. So there was the advert. I filled in the slip, sent it off to them, and they wrote me a letter back saying, oh, since you're actually doing an HND, you can qualify and go on our direct entry engineer program if you pass the interviews. Because if you were a technical assistant or a TA, they would train you to be a broadcast engineer in 2.5 years. If you went in as a direct entry engineer, you did it in a year's time. Hello, Malcolm. Welcome. So, you should have given me a ring.
Well, I tried to.
Okay. So anyway, they said, we'll see you at the milk round interviews at the university. So that's where I went. It's worth saying a little bit about the interview process that they did back then, because these days they would never get away with it, I'll tell you that now. The first interview, the rough selection thing, was they put you on a schedule, and when your time came for the interview, I walked into what was basically a broom cupboard, and it had a table in it about this size and 2 chairs, and that was all you could fit in there. So I just sat on this table opposite a guy, and this guy was in a suit and tie, and he had no visual facial expressions whatsoever. He never smiled, he never blinked, there was nothing on his face to portray any emotion whatsoever, and he just sat there and said, you know, welcome to your BBC interview. And he had a big stack of cards like this, and he just slapped the cards down on the table one at a time, and every card had a circuit diagram on it, or an Ohm's law problem on it or something, and it was just like, boom, what would be the voltage at this point? And you'd answer the question, and he'd take it away with no comment, didn't tell you whether you were right or wrong, you couldn't read anything from his face. He'd bring this one out going, how might you improve that amplifier? What would be the wavelength that this aerial's tuned to? and just on and on and on and on. And every now and again, when I'd answered something and I know I'd got it right, he'd pause and he'd go, "Are you sure?" So I was like, "Yes." And this just went on for about 30 minutes. And then at the end of it, he said, "Well, thank you for coming." He said, "We'll let you know." And I walked out of there thinking, well, blow that for a game of soldiers. I didn't want that job anyway. And I was extremely shocked when I got a letter in the post 2 weeks later, actually inviting me to London for a second interview. So I thought, I must have done something right in there. So I went down for the second interview in London, and this one was different again. Found this place, I can't remember where the heck it was, but you sat outside and there was a big waiting area full of different people waiting for interviews for different things. And when they called your name, I went in through this door, and it was one of those throne room setups where you have to walk down a long empty room to get to an exalted desk at the end that had 4 people sitting behind it, and in front of the desk was just one chair, designed to completely intimidate you, you know, the walk of shame when you got there. So I got up there and, you know, they said, "Oh, welcome, you know, take a seat." I sat on the chair and it collapsed. Because they'd rigged it to collapse. They did it on purpose. And I think it was just their way of saying, let's see what happens when we put them under pressure. I mean, they would never get away with these tactics these days. On so many levels. I can't remember what I did. I think I swore at the chair and shoved the remains to the side and said, "Does anybody have another chair?" Which was pretty much the only thing I could do. And I guess that was the right thing to do. You know, thinking on your feet and dealing with the situation. So anyway, I passed the second interview, and subject to a colour blindness test and a hearing test, I was then employable, and I got the job. So that was great. So the first thing they did was pack me off to the BBC Training Centre at Wood Norton, just outside Evesham. There's an aerial shot of it. And basically what they have at Wood Norton is everything. They have 2 complete TV studios. They have radio broadcast studios in all the huts, mainly up at the top there. They've got TV transmitters, they've got shortwave transmitters, they've got all the different gear and equipment that the BBC uses, all running into dummy loads, not live on air, but big dummy loads, and they just train everything. They train lighting engineers, broadcast people, there's people who do the sound. They do everything there. And they've even got big studios and everything on that site. Rumour has it that there's also a nuclear bunker underneath that site. It's not a rumour. I can tell you firsthand. Being on the transmitter cohort, we were always a bit antisocial and we did crazy things and we went urban exploring and stuff like that. And we found at the back stairway of one of the studio buildings a staircase going down. So we timed it, we decided to go down there one evening after everything had finished but before it started getting locked up for the night. And we went down 6 floors and the staircase was still going down. And we got to the 6th floor down and we started bricking it thinking, you know what, there might be security cameras down here, there might be micro switches on the door, and we started thinking as if like, we might lose our jobs, or worse. So we actually retreated and went back up the stairs and never did it, but you can go down at least 6 floors underground, under there, and there's something further down than that. If you read it on the internet, apparently there is a bunker under there, and it's designed to keep the broadcasting network up should everything else be vaporised. They could actually send anybody who was still alive to Wood Norton and they could do TV and radio programmes from it. But there you go. So there's a little anecdote for you. Strangely enough, most of the BBC transmitting stations also have little mini bunkers underneath them. Got some photographs for you later of one of them.
Yeah.
So that was that. After qualifying there, they then sent you around all the different stations. So you went to Daventry for your shortwave training, you went to Sutton Coldfield to learn about TV, and you went to whichever home base you've been allocated to work on everything else. So we'll come to those as well in a minute. So let's talk about Daventry, which is where I went during my training to learn about HF, or World Service as it is. Daventry's down in the Midlands. It's not too far from Droitwich and Worcester. It's that sort of area. It's was a massive site because it's closed now. The only HF station, the only World Service transmitting station still running, I think, is Wufferton down south. Skelton, where I worked, is gone. Daventry, where I worked, is gone. So I've got photographs of those that you will not see again because they're gone. So that, if anybody's interested in history, is the 5XX building at Daventry. You can just about see 5XX up there, which was one of the old, I think it was a long wave transmitting station way back in yonks ago. When I was there, that building was just a storage hut, basically, but it used to have that inside it, which was the old stuff. And interestingly enough, when I actually was on shift at Moorside Edge, just on the mountains up there across the M62 on the way to Huddersfield, the old transmitters that they used to have in there looked something like that. Real museum pieces they were, and lots of fun to work on. So that was a 5XX building. If you went into the main transmitter hall, when you went in through the double doors and went past reception and everything, the first thing that you would see is that. And that gives you a kind of a picture of the environment of what it was like. Very nice polished wooden floors, transmitters all the way down both sides. What you're looking at there is 100 kilowatt dual band shortwave transmitters. So each of those banks of doors could transmit on two frequencies at the same time, 100 kilowatts on each. So they were dual output. And just up the back end there, near the vestibule, there was a couple of SSB transmitters, which they used to use for Foreign and Commonwealth Office international links. I never really figured out what it was that they broadcasted, but we were responsible to keep them on the air. So that was the way it was. Yeah, who knows? Who knows? But beyond those doors, you were then into another area which I'll show you a picture of in a minute, which had some very old transmitters in it. And if you were to take a left turn in the hallway there, you would go into the area where the 250 kilowatt transmitters were, which I'll show you in a minute. If you were to turn right instead, you could then go up a staircase, and the control room was up above there in that sort of area behind the clock. In fact, the little thing up there that looks like a plaque on the roof was actually a window that could be opened up with blinds, so the operator could see down into the transmitter hall if they needed to do so. And I'll show you pictures of all that as well in a minute. Speaking of the operator, that is the control desk for Daventry. There was one engineer who used to have the job of doing that. That was a nice coveted position. None of the trainees got that because it was a DOS if you were on there. It was a DOS, but you had to keep your concentration. You couldn't afford to read a book or something. You had to work for the whole time. Because the way the World Service worked was everything worked on a schedule, and every 15 minutes something happened. Sometimes lots of things happened on a 15-minute switchover period. And you'll see a big board there that this chap has got. That's the master schedule, and that will be sent up from London. And it's basically tram lines down it with the time, and each line represented a transmitter on site. And it would tell you for this particular period of 3/4 of an hour or whatever, we want this particular transmitter's got to be on this frequency, on this aerial, which is set to this bearing, and it needs to be carrying this program. So there were various audio feeds coming into the station. World Service in English was always coloured green. There was Voice of America, which I think was blue. Can't quite remember what colour it was now. And then the other main one was Arabic, which was always purple. You could listen to them on the desk as well. Voice of America was always like, "This is the Voice of America." in special English, which usually meant they used very short words and simple to understand for people who were challenged in that basis. The World Service was the typical thing. This plummy mouth guy used to come on and go, "This is London." And then he used to play Billy Bolero, you know, and you just want to stand up and do that, which I think was the idea of it. So this guy on the selector board up there has got a big matrix of controls, and each one of those represents a transmitter against an aerial or an array. And then the other one is selecting the audio feed that each transmitter is going to be receiving, and he would set all that up on his pegboard, and then when the 15-minute period came around and the clock triggered it, the automation would click everything over onto that new set of settings. So he always had to be 15 minutes ahead. And down on the floor, the people who were actually running the transmitters also had to be ready. So they had the copy of the same schedule, and that same paper would tell you this particular transmitter is going to go off air on the hour, and 15 minutes later it's got to come back on the air on a different frequency. So you'd have to wave change it and everything, get it ready, dial in the frequency it needed to transmit on, tune it up, and then put it back onto auto, ready for the scheduler to pick it up and do the thing. So this was night and day, all the time, round the clock, 24 hours. Because obviously they were broadcasting to different places all over the globe, and things had to be sorted out. So that's how it worked. That is the Daventry aerial control panel. So the guy, that's just behind the desk where the guy was sat. So each of those represents an aerial. The keys at the top are for locking it off, you know, to isolate it so that nobody could put a transmitter into that array while some poor git was climbing up the mast to adjust some bolts. So they were responsible for the safety. And all of this down here was setting the different bearings, because these arrays could be varied in configuration, steerable to a certain extent as to whichever aerial they wanted to reach the target area was the one they selected according to the schedule. You didn't have to figure that out, it was all done in London, you just had to make it happen. So that's the array. You can see the different numbers of the arrays, you can see how many there were on the site. If we move along a little, that's not a very good picture, but that is one of the, they called it a Matheron switch. So that's basically on a base plate, a bunch of vertical sections there made of some sort of paxolin, and the feeders would come in, and then the switch mechanism there, the arms would go up and down, so you could select between this feeder going to that or that. And the actuator was driven by compressed air. They tried it with electrics at the first thing and it never worked properly. But there was compressed air lines going out into all the fields, and that control panel that you saw would turn the right ones on to make the right adjustments for the aerial, select the right aerial, the beam width, the direction and stuff. So you got probably, I don't know, 50, 60 of those all spread out around the site, all doing their thing. That's a typical shot of what it was like. The little, what looks like a cattle shed down there, is actually a bunch of those switches with a roof over it to keep the worst of the elements off. But you can see the feeders that they used. We used to call them sausage feeders. It was basically a twin wire feeder made up of like 5 or 6 different wires in a sausage. And so that was, and they were about that far apart. That was like what the feeder looked like. And you can get an idea of some of the, you can see some of the arrays there. It's not a very good picture of it, but what mostly they were was like arrays of dipoles. And the way they would actually phase them would be to switch in different lengths of feeder. So you might have a big length of feeder that just went round the site and came back again for no other purpose than just to introduce a little bit of delay. So you could feed one dipole directly, you could maybe feed the next one or the one in the next bay, or the one that was behind it acting as a reflector in a slightly different phase, so they could skew the direction that the array was going to work in. And that's pretty much what they transmitted into.
Are the towers climbable,
Yeah, they are. They used to have a rigging team whose sole job was to keep all that lot in the air, hence the locking off. those riggers were mental. There's no other way to describe them. They would climb up those things like it was nothing, and they would sit literally on the top eating a sandwich or
With
something.
the legs dangling over
Yeah, with the legs dangling over the side. They varied, but there was
at least 500 feet.
oh yeah, they were big masts,
Remember the ones that
and they'd be up and down them like monkeys, and they'd do that all day, every day. You know, adjusting the tension on cabling and replacing bits that got weathered and stuff like that. They were absolutely mental. Never seen anything like those guys. So that gives you an overview of it. So let's look at some specifics now. The 250 kilowatt HF transmitter that I mentioned, I'll go a little bit quicker through these. That's a picture of one at Wufferton,
To go inside it.
because it's a better picture than some of the ones I took, so I'll put that on just to give you an idea. So basically what you have here is that is a 250 kilowatt audio amplifier. It's the modulator. That, behind the guide, is the actual 250 kilowatt RF output stage, and that is the driver, which produces a mere 5 kilowatts. Sure you'd like that in your living room.
Yeah.
And that's not all of it, because behind there, which you can't see, there's an EHT room, which you've also got, and the cooling plant and everything. As trainees, we were expected to know every nut, bolt and washer in that equipment. And the exam basically is one of the senior guys who've been there since like Noah had parked his ark or whatever, would just get the drawings out and say, explain this part of the circuit to me. And you had to be able to tell them exactly how it worked and what the function of every component in there was. And don't forget, we're not just talking the electrical part here, because as you'll see, there was some serious cooling systems involved in this, and all of those had to be interlocked together, because if the cooling failed, it was going to be bad. So there was lots of electromechanical stuff to think
How
about
did they
too.
modulate the RF?
High level modulation.
That transformer.
Oh yes,
Transformer.
transformer. That is the same thing at Skelton. That's Sender 51 at Skelton. I actually worked on that one. Wave changed that one personally. That's gone now as well. Cumbria, just outside Penrith, Skelton was, in the forest. Again, you can see a better view there. You can see the RF section a lot more clearly. The modulator is to the far left. You can see the handles on there for tuning, because everything was dual. So you had two sets of handles. The meters at the top there would give you the indications you tune by. You can see the papers on there as well. That was your crib sheet. So if you were required to put the transmitter on, I don't know, 4.2 megs, you'd look on there and it would give you 4.2 megs, and it would give you the starting position to set all the handles to, because each of them had a numerical readout on. And that will get you in the ballpark so that when you turned it on, the thing wouldn't trip off. And from there, you would fine tune it and get it into the position it needed to be, which was all done manually and by eye. And this gives you a much better view of the driver section here, that used to just generate the exciter basically for it.
What would the meters be monitoring?
Current, voltage, on all the different stages.
Well, he cut his finger.
See some of them soon, and a few breakers there for tripping off supplies. The all-present isolation panel with the keys in it, so you could lock things off if somebody needed to work on it.
Just how much RF was there in the area outside?
Quite a lot. But if you imagine that site, so I mean I was working all day every day on that site, surrounded by megawatts literally of HF radiation. So I don't have a lot of time for these people that whinge because they want to put up a mobile phone mast within 5 miles of their house that transmits microwatts. It's a load of old baloney. It's non-ionising radiation. Otherwise all of us who did this will be burnt to a crisp in 5 minutes. So it's fine, folks, it's alright. But yeah, that was Skelton. Here's another view of Skelton, not a very good view of Skelton, but it gives you an idea of the main 250 kilowatt hall in Skelton and how many of those there were.
You were talking about.
Now bear in mind that when you were on shift, on any 15-minute switch period, you might have to wave change 2 or 3 of those. You got quick at doing it, I'll tell you, because you've got to wave change them, you've got to tune them, you've got to select the frequency, get it set up and put it back on auto, and you've got to do all that at 3 o'clock in the morning, and you're racing against the clock. And the other thing you don't realise from that photograph, it was flipping hot in there. Even in the winter, we would run about on shift in there in shorts and t-shirts because it was so flipping hot. It was hot.
Anywhere down south.
Back to Daventry. This is actually these are photographs I took at Daventry. So you can see here that's the modulator. There's the RF section and the driver beyond it. A little trolley there with all the tools on. Through the door there, it would take you into where you could get behind the transmitters to get to the EHT room, which I have a photograph of. Speaking of, go on, question? I thought it was a question. No. Speaking of EHT, these used to work directly off the incoming 11 kV mains supply. The final supply to the RF amplifier was 11 kV at 22 amps. That was what you were tuning for on the meter. When you'd actually got it, you'd adjust the loading to actually get 22 amps. 11 kV, 22 amps, you do the maths. And that was only the high voltage supply. I think the heater supply for the finals was something like hundreds of amps. It was low voltage, but it was ridiculous levels of current. That's a view into the, obviously that's a freeze frame photograph, but that's a view into the EHT cabinet. You can see there the mercury arc rectifiers actually rectifying. And that gives you a picture of what it looked like from the outside when the transmitter was in full voice. You got a beautiful blue glow, and that's flickering and moving. It looked like something out of a Doctor Who picture. There's a picture of the back of the transmitter, the EHT room. Yes, it is the right way up. You can see the general type of construction. A few interesting things here. At the back there, you can see one of them is the HT smoothing choke, and the other one is the modulation transformer. So basically what they do is they put the HT for the RF final amplifier through the transformer and then stuff 250 kilowatts of audio into the other winding and just modulate it by the brute force method.
Level of modulation on it.
They went up to about 80%.
Yeah.
Yeah, AM, all AM. Yeah. These capacitors here you had to be very careful of because they were actually filled with oil that contained PCBs, so they were cancer causing things. So part of the maintenance routine for this was every now and again when the thing was off, somebody had to go in there and just walk around and visually inspect them to make sure there wasn't any oil leaking out, because if there was, it was bad news and it had to be sorted. And these interesting looking things over here that look like, you wonder what they are? They're resistors. So it's basically an asbestos mat with the resistance wire woven into it. So that was what they were as well. But you get the general view, and there was that behind every transmitter. You can also see it has no ceiling, which is a design feature. So if anything actually blew up or caught fire, the fumes could go up into the sort of the mezzanine bit at the top. They could open windows and let the smoke out, rather than it being an enclosed box that would then become very difficult to get into. There's a picture of the inside of one of the modulators, so that gives you an idea of the size of the valves that were in there.
Yeah.
So the valve would sit in a water jacket. This is actually sat in a cooling jacket here. The pipe just on the extreme left would be taking water vapour out. So the cooling system was pressurised such that the water changed instantly from water to steam. It didn't boil, it sublimated. And the idea of that was the boiling would be inefficient and rather disruptive. So water came in, steam went out. That pipe was made of sorts of Pyrex stuff because obviously the voltage, that thing was at 11 kV, all that. and the water had to be kept at a certain level of purity to avoid leakage current through the cooling system. You'll also see odd little things like that strange looking drain pipe over the top that was just blowing in cold air at a particular strategic point just to cool something down on the valve that got a little bit over hot. You quite often had things like that. And this was in one of the side doors of the unit. You couldn't get into this and open it when it was on power because all the keys were locked into that panel that I showed you. You had to actually power it off to free the keys up to be able to open the doors to get in and work on it or wave change it. That's in the RF section. Nice big vacuum variable capacitors. And they would connect by rods to those handles that you saw on the front, which is how you would tune the thing. And that's a picture of, gives you another idea. There's the cooling jacket with the valve sat in it, and there's the glass pipe there. Notice how everything's rounded as well to avoid flashover. This thing here that looks like a manacle, you'll see what that is in a minute.
Oh no, I know
So this is a final compartment, and this was what we're talking about when we speak of wave changing, because you physically had to change the coils to suit the band that the machine was needed for. So what you can see here is this is a truck. It's a motorised coupling truck which used to trundle backwards and forwards, and you had one coil that fitted on there. You had one or two coils that went on that connected to the anodes of the valves, and the one would slide in and out of the other. You had a pair of buttons on the front where you could send it forward and back to get the right level of coupling. For certain frequencies these knife switches had to be engaged, and for other ones they had to be disengaged. There was a brilliant one inside the door on each side. There was a big carbon resistor with a knife switch across it connected to nothing. But on certain frequencies, if you didn't have that closed, it would be unstable. It just, you know, they'd figured this out somehow, and it was just part of the thing that you had to open and shut this switch. Yeah, exactly. Couple more shots. There's a picture of, I think that's probably the 2128 meg coil. So you can see that there, connected to the anodes. So for wave changing, you'd have a spanner, you'd undo those two big bolts there, you'd take that whole thing off, remove it, you'd remove this one by undoing those two bolts, take it off, remove it, take it out, and then bring the other coils in that were needed for the next frequency. You bolt those into position, make any adjustments that were needed. Do the same in the driver stage, the one in front, that had two coils in it as well, that sometimes had to be changed. So you've got all that to do. And the other thing, remember, is this thing had just been generating 250 kilowatts. They were hot. There's a view into the driver's stage. So you can see there's a coil there, and a chap there with that's why he's got an asbestos glove on and his special spanner, because he needs to change those. And notice the valves are still glowing. This thing is still ready to power up. It's just the EHT that's off, because you've only got 15 minutes. You can't shut it down. No time. And there he is again, disconnecting that coil, which is a nice big fat one, look, and that one there, and he's got his gauntlets on. Special spanner. Again, everything is rounded to avoid flashover and arcing. And there's the two final output valves. The door behind him, I think you can just about see the micro switch on the door there with the resistor just behind the guy. And that was about how much room you got to work in it. It was like a small box room basically.
Were there weight in them as well?
Oh yeah, they were heavy. Yeah. That's what you had next to each transmitter. So you had like a rack with all the different coils in there. And notice the chicken stick. If you ever had to work on it, you were any doubt, you went in with that first and prodded it in there to see if there was a ruddy great bang. Every transmitter had one of those as well. So yeah, I dropped one of those really big coils once because it was just too hot, and it started burning me through the gloves, and I dropped it and bent it. So they sent me off to the workshop and said, "Brody, fix it, lad." So I had to go in there and hammer the thing and sort it out. That's the 250 kilowatt. They had some even more ancient stuff. The 100 kilowatt Swab 18. These things were well old. That's the Swab 18 hall in Daventry. You can see what kind of vintage we're looking at there. That's the control desk, better view of it. That's the Swab 18 hall at Skelton. You can tell by the upholstery on the floor. These, fortunately, you didn't really have to wave change very often. Perhaps once or twice a week, because they were a lot harder to do. A lot harder to do. Those things, forget all your stuff about it. Every voltage for them was generated by motor generator sets. So you had a big hall full of that stuff behind it. It looked like something out of the Titanic. All the switch gear, so they were all thundering away, generating all the different voltages for those transmitters. And underneath it, you had what was strangely called the cooling crypt, which was like hotter than hell and very noisy. And that was where the cooling water was circulated for the transmitters that were above it in the hall. Power, mercury arc rectifier, all good stuff. And there's a view from above one of them, looking down on it, so you could see the mercury arc rectifier there in its tank and the links across. There's one of the valves that would have worked in one of those. That's just the valve itself. It's not in its trolley. Its trolley looked like that. So the valve will be sitting in the top of that. And these strange looking tubes here, unfortunately I haven't got a picture of one with it actually assembled. But that was called the serpentine. So connecting each of these would be like a U-shaped ceramic pipe. So if you imagine all of that lot, all these links on this side and all the same links on the other side, it basically made a long ceramic serpentine. The whole idea of that was to get enough distance between the high voltage on the valve and the output where the water came out. And when it was running and the water was going through it, it used to make this just weird moaning noise that you can't describe, you just had to hear it. And every now and again there'd be a big bang when something would trip off in one of these. But what you really, really hoped was there wasn't a big bang followed by the sound of water, because that was a real mess when that happened, because it meant that one of them had sprung a leak and you were knackered then. Everything was wet and you were dealing with wading through this water and messing around as well, which was never good fun. So that was my experience on the shortwave station. I've got some pictures of Home Moss now, which is a little closer to home. Home Moss is up on the mountains, as you possibly know. I used to ask when I first went up there, and I said, why do they have those little poles at the side of the road? And the person who was answering said, because when it snows, that's the only way you can tell where the road actually is. And believe me, I've driven up there in some snow.
Exactly what you mean.
That's a picture of the outside of Home Moss. That was the door that I went in and out so many times. These are the offices here. This was the workshop area where they used to do a lot of the maintenance. And behind it was the garage where they had their 2 Range Rovers and 1 Land Rover, because they also used to go out and service all the mobile sites from there. So that's quite an old picture of the Moss. Speaking of the snow, it used to get like that occasionally. There was one time, several times actually, when we were just snowed out and could not get in. One time I remember I hooked up with a couple of mates of mine who actually worked up the Moss, who came from the other side. I was living in Sheffield at the time, and they said, oh, the road's going to be open from Home Firth up onto the Moss, because they've got the snow blower and it's going to go up. So if you can get to Home Firth, and meet us, we'll go up in the Range Rover behind the snow blower. So I got there, met them, the snowblower was going up, we were going up with difficulty behind it in this Range Rover, and every station had a guy on it called the technician, who basically, in the station, he had a machine shop, he had a lathe, he had a milling machine, and anything that broke, he would make a new one. Really skilled machinists, and every station had one of these. And the technician at Home Moss at that time was a wiry guy, thin guy with a beard called Will Leonard, proper mountain man. And as we were going up that day in that Range Rover in all that snow, following the snowblower, we got almost to the top, And what did we come across? Will Leonard riding up the mountain through the snow on his push bike. At which point we stopped and said, Will, thank goodness we've spotted you. Throw your bike in the back and we'll take you the rest of the way. And he looked at us with this withering look and he said, has it not occurred to you that I might be enjoying this? And we let him go. And literally he came in about 15-20 minutes later, parked up his bike and went to work. And that was the kind of people that those guys were. There was another very famous one who worked at the Colbeck station, who went down in history. He was Colbeck Willie. And he was a fell runner. And his method of training himself for fell running was he used to leave the station when his shift ended in his shorts and his little vest for running. He would pick a sheep and he would chase it. And wherever the sheep went, he would run after it. And he would run and run and run and run and follow the sheep no matter where it went, no matter the terrain, until the sheep dropped from exhaustion. And then he would go, right, I've done enough.
What did the farmer think about that?
Who knows?
No buckshot will be that.
But that was the kind of people you were dealing with on these stations. This is a picture I took of the Home Moss Radio 2, 3 and 4 FM transmitter hall. You can see there, this is the incoming PCM feed that brings the digital audio into the station. And you can see there you've got Radio 2, Radio 3, Radio 4 driver bays, and actually FM modulators and everything, and a bit of control circuitry. A couple of valves there on the table, and the ubiquitous torch. So that was, you get the idea of the kind of stuff that was on these stations.
How did the feeds come in, Alan?
Sorry?
How did the feeds come in? Telegraph wires?
No, it was a fibre. So it was quite interesting.
Advanced, yeah.
But like the mains, every BBC transmitting station had two separate signal feeds coming into it from two separate places and two separate main supplies off two separate grids. So if there was any problem, the other one would keep going. They all did that. In the case of Home Moss, it was a damn good job they did. We'll come to that later as well. That's a typical mimic panel showing the layout of the transmitters and everything, and the way the aerials were combined and could be switched over. So if there was a fault, if something tripped off, you could go in there, you could look at that mimic panel and it would tell you what had happened. So that was your first port of call. There's another view, kind of the FM transmitter hall, and I've got a few there. That's one of the ones with the front open, so you can see the final valves in there. That's Radio 4B, so there was an A side and a B side combined. You can't see those meters very well, but that gives you an idea. And then I decided I was going to zoom in a little bit, and then I realised I really couldn't see it well enough, so we went for that. So that was 100 kilowatts each side. Times 3. So there's quite a lot of power being radiated there. That was the combiner and aerial switching area at the back of the transmitter hall that you just saw. So these are the switches coming in, the feeders from the transmitters, tubes going up to the aerial. What you can see here is a water-cooled dummy load, and the same on the other side. Never really had to do much with that, but if there was an emergency, you had to change over one feeder to another or something. You'd have to go in there and switch stuff around. That got replaced by these. They were the more modern ones. There was a complete new hall built with more modern solid state stuff in it, and a complete new mast was put up because it was just easier to just duplicate everything. So they could build all this and get it working while the others were still on the air, and then at the appropriate moment just switch over. So I saw the transition between the old gear and the new gear. I saw the new gear come on, the old gear get turned off, so that's quite interesting. There's also other stuff there. These were the drive bays for the 3 local radio stations that used to get transmitted from there. Then you've got incoming supplies there. The last 2 on the left there, before the other cabinet, is the MIC, the monitoring centre, which I'll show you a picture of in a minute. And then way at the back there is the standards converter for the old band 1405 line TV transmitter, which also used to radiate from Home Moss. Speaking of which, there it is in all its glory. And that was real old stuff. And my claim to fame is when Band 1 transmissions from Home Moss ceased for the very last time, I was the one who pushed the button and turned it off. It was me. This finger did it. So there you go. And that's the couple of the local radio stations. Sheffield local radio, I can't read what that one is, Manchester. Their gates 1 kilowatt FM transmitters, all combined in one cabinet. The monitoring centre. There's the desk. Don't know who that is. Very, very relaxed there. But I'll show you a better picture of it actually. One engineer, like at the shortwave stations, got the job of sitting on there all day. I did that a few times. It didn't matter what you watched or listened to, but you were required to watch or listen to something all the time, just as a quality monitoring thing. But your main job, apart from doing the weather forecast 4 times a day, you had to do the weather observations and phone them into the Met Office, because they were a monitoring station, was speaking to the mobile teams. You got a microphone there, and they had a radio which had incredible coverage from up there. Could work all over the patch. All the Range Rovers had RT in them, and monitoring the remote stations as well. Now remember, these are the days before real computer stuff really got going. When that photograph was took, where the BBC Micro was just beginning to become mainstream. So they really didn't have computer technology like they did now. All of this was done sort of semi-analog. So on all these remote stations, and there was probably 30 odd that Home Moss used to monitor, they were picking up the transmissions from Emery Moor, rebroadcasting them into some little valley or whatever on a different TV channel. They all had a little monitoring unit on it, and if it had a problem, it would phone up Home Moss on a telephone line and report its status by a series of beeps. And then they had technology there in those racks I showed you that would actually think, oh, what is it that's calling me? What's the telephone number? It would listen for the beeps. So, you know, if you listen to it, you could actually dial them up, and you'd hear the thing at the other end answering. It would just go something like beep, 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 beep. And that was each beep, a beep or a burr was saying something is good or something is bad, you know, and so the machine knew, and you get a display up there on the screen that would tell you the status of these different stations. So it was all good fun, really good fun. And all the cards there were all the different stations that the guy could dial. He could drop them into his dialer, and the dialer would dial it, and then it would interrogate the box at the other end and get a status. So that's how they used to monitor everything, old school. Going back to that, you can see the keyboard there where he could bring up the stuff. You can see he had a nice scope in the front there, so whatever he was watching, you could see the video waveform on it. And you could tell when it went to opt-out in the evenings, you know, when it went from the national news to the local one, because you could see the video waveform go, because they really couldn't generate a decent video like they could in the centre of the regions. So that was always amusing. That's a picture of one of the remote sites, typical one. That's actually a bigger than typical one. That one is Morecambe Bay. That one actually did used to get its signal from Home Moss.
Where's that, Alan?
Morecambe Bay. So those two Yargies there were pointed at the Moss. It would be receiving the TV signal from the Moss. Then it would be demodulated and rebroadcast to the local area on a different channel. And usually there was one block for IBA, one block for the BBC, and a sort of a communal block in the middle that had a composting toilet in it or something, and if you were lucky, a kettle and a chair. And that was basically what you got up on the top of these mountains. That one is a little bit closer to home. That one is at Bakeup, so that's a lot more nearby. And you can see there, this is much more typical. There's the entrance with the communal area in the middle. That side would probably be BBC, that side would probably be IBA. They'd have the reruns in there. So that's, I used to drive around in a Range Rovers and have to go out and fix these things and do maintenance on them. I mentioned the bunkers.
What was that one, Alan, before you moved on?
That one, vehicle. That's underground at Holmos. I'm probably not supposed to have this picture, but it's there. So this was an area, you went down a staircase that nobody went down, and there was a big door like you'd see on a submarine or something, big metal door. You went in and then there was basically 2 concrete rooms. You had a very little control panel in there for the generators. There was a little mixer and a microphone under there, a pair of headphones and a clock, and a pegboard there so you could pick up the incoming lines. I mean, I don't know what they were thinking. If you had to actually retire to that room, what are the chances of there being any infrastructure left anywhere else to send you any programs? But they had one of those at Daventry as well, underneath the station.
With all the sheltering on the
Yeah, yeah.
doors.
And there's another view of it. There was a bog in there and a little... what used to happen is when the people were on night shifts, they used to go down there for a kip, basically. That was quite common. There's the mast at Holmos. Fred Dimner famously climbed that while I was on shift and did a live broadcast on Radio 2 from the top. Famously swore on the BBC. Said, "It's bloody cold up here." And it went out live on air. But you can see there they're building the new mast at the side of it. Now you'll see a picture later off of the bottom of that mast, and it's quite interesting.
Have you ever been up one?
I have not been up this mast.
That's those 2 white boxes.
Which?
Yeah.
Troughs. Trough aerials for microwave, yeah. So it's basically a trough, that's some sort of fiberglass over the front, and if you were to take it off there'd be dipole elements or something banked in there. They used to do a lot of outside broadcasts from up there as well. There was the OBs would link in using the dishes and stuff, and then they'd send it down to the studios from Holmos for whatever they were doing when they did an OB. There was a famous incident with Holmos and the ice, which now you're never going to see these pictures anywhere else, I'll tell you that. So February 1986, I was on shift, and for nearly 4 weeks we couldn't go into the station. So we sat at home on full pay, and we had to ring in every couple of days just to say, "Do you want us in yet? Do you want us in yet?" And they said, "No, stay at home, stay at home, stay at home, we'll tell you when to come." And what was going on, if you can see the stays of the old mast there and how much ice there is on that, there was so much ice up there, there was tons of ice on those stays, and they were mortally afraid it was either going to bring the mast down completely or cause some serious damage and possibly kill somebody. So they said, "You've got to stay at home."
Well, that's what happened at Emley, isn't it?
That's what, yeah, the ice brought the thing down at Emley, and they were really
Tremendous
afraid.
waves in that house.
Tons, tons. Well, you'll see in a minute. And of course, it happened, didn't it? That was the. That was a rather short news report about it. So the day after it happened, I rang in and they said, "Yeah, come on in, there's an awful lot of cleaning up to do." So I went in and I said, "Do you mind if I bring my camera?" They said, "Go for it." So I did. When I got there, that's what we found. That's the roof. Literally tons of it had come off the stays and just literally gone straight through the flat roof and into the building inside. So that was, you could see there, you were walking on the roof and you can see the bottom of the old mast just at the top there, and it literally just devastated things. That's one of the engineers there looking at, that's actually the remains of the HV switch room. He's looking at an 11 kV breaker there that's been a little bit ruined by a block of ice. There's another view of it. That's him attempting to rescue a transformer, and you can see how much damage it actually did. There's a little bit better view of kind of the extent of it.
Give me 1 second.
Pretty mad. Can you imagine the power of that when it came down? That's looking down through one of the holes into one of the rooms. That was the battery room. The 11 kV switch room was next to it, and that room had like the batteries in because they had to be able to switch even when there was no power. So it used to be battery powered. There's another nice view of a big hole in the roof. Just went straight through.
It's easy peasy. First time happened.
There's another view of the same guy attempting to sort things out there.
The printer.
That's a view down through another hole in the ceiling. I think that vent used to be on the wall somewhere, but it's now down there.
No, I put it there. No, it's
And there's another one. That's the switchboard he was attempting to work on at the time. Another nice view there. It was blinking cold up there as well, but it was worth it to get these pictures. That's attempting to clear up just the mush because everything was just so full of water as well. It just went crazy.
just put it in there.
That's showing it that's rebar there, so reinforced concrete. It just smashed through it like it was made of nothing and destroyed it.
Doesn't carry its charge much, does it?
There's another view. Now that one's quite interesting because you can see the bottom of the old mast there. You can see it comes to a point. It really did come to a point. Yeah, the whole mast was sat on a vast ball bearing at the bottom, and it was actually the guy wires that kept it upright. Just the weight on the ball, and it meant it could be moved and adjusted. And it was the bottom of the mast that was getting defective apparently, which is why they had to build a new one, because they were afraid it might go, and they were mortally afraid it might go with the ice. There's another view down, that's the HV switch room there, the CO2 warning and the battery charges covered in bits of asphalt or whatever. Yeah, there's a really good view of the bottom of the old mast, showing where it came through the roof. And that's basically the end of the slideshow, except to say, remember I reminded you at the beginning that all stations had 2 incoming 11 kV feeds from 2 different places on the grid and 2 sets of audio. Well, because of that, even though you've just seen a complete HV incoming side of the station destroyed, it carried on because it still worked on the other one. And even when that went, if both of them happened to go, there was always generators on each station, which were a lot of fun because once a month you got to run the standby diesel. One of the stations actually had a gas turbine. I never got to actually run that, which was a great shame, but just running the big diesels were good enough. And you're talking big diesels, the ones at Moorside Edge were enormous, they came out of a ship. Each engine was about the size of this club, and it was like 2 levels, you climbed up a ladder to get onto the top. And the noise when it was running was terrific. Used to scare the proverbial out of the new engineers. We used to make them go in there and do things. And, yeah, well, I loved it. It was good fun. So that was the job. Why didn't I keep doing it? Well, they promised you when you started that you'd be on what they called the reserve pool for maximum 18 months. Maximum, they said. And then we'll find you a place on a station, a permanent post, and you can move your family there and you can settle down. They lied. I did it for just over 5 years on the reserve pool. And what that meant is you could be sat at home, you could be working at home, Moss, you could come home. Wednesday you come home after work, Wednesday evening you get a phone call and they go, oh, on Monday morning we want you up in Skelton please, for 6 months. And somebody who's been married less than a year, and later on we had our first baby on the way, it used to wear a bit thin. And they give you a permit, you get to come home, but because you were on shortwave, you were working shifts all around the clock. I might be home on a Tuesday and a Wednesday. When my wife was working, she'd get Saturday and Sunday off like all normal people. So we weren't seeing each other, and it just got a bit ridiculous. And out of the 20 odd entrants that was in my entry when we joined, I think it was 21, 22 of us went in. By the time I left, it was 3, because everybody else had got brassed off with it and left. And now, of course, there is no transmitter group anyway. But back in the day, the BBC used to have their own, run all their own stuff, as did the IBA. There was a separate parallel organisation for them. And now all the assets, all the transmitting stations and the masts have all been taken over and outsourced to Archiva. So there's a handful of people that actually work for them, but most of it's just automated. It clicks along. So what you're seeing there is a bygone era.
Yeah.
But that's how I learned most of the stuff that I learned. So there you go. I'll put all the pictures up on the website, on the club site, if anybody wants to go back and look at any of those in more detail. And if anybody's got any questions, I'll do my best.
Many years ago, this radio society had a trip to Embley. One of our members was an engineer there, and that was extremely interesting. And they had a similar problem with ice. I think it was something like 220 tons, was it, of ice on the cables that held the transmitter. And that's the reason that the present Embley transmitter is concrete. There are no guy lines at all. And the twin of it on Winter Hill, apparently they feed all the hot air from the valves and the semiconductors and whatever up the mast.
They do.
Yeah.
Yeah, I've worked up on top of Winter Hill as well. I've been up there on shift.
So how did they handle the problem with the ice on the cables? Do they wrap them around with a heating wire or something?
They're just okay with it, I think, with the hot air going up the mast. The other thing that they learned after the tower at Embley Moor fell down was once it starts going, it starts to oscillate. So inside the Winter Hill one, from the top to the bottom, there are really great chains hanging down.
Just to
And
damp
so if
it.
the mast starts to move, the chains start to move, and it dampens it.
I remember Mark telling us that they couldn't use the lift quite frequently, even in light winds.
Yes. I've been up that lift several times. It takes about 6 or 7 minutes to get up to the top of that concrete tower in the lift. It's a very slow lift, but the view from the top is well worth it.
That's one of my regrets. I gave up my place to somebody else.
Yeah. Oh, you should have done it.